Okay, because some students still are under the quarantine, so they cannot be here. So I have to record the course and then post it onto the Cyber University. Okay, so only I am recorded, so you don't have to worry too much. Okay, so today I'd like to introduce the battery management system. Last week I introduced some kinds of batteries, and this week the management system. Okay, and first I will do a little introduction to the battery management system, or BMS, and then I will spend a lot of time discussing about the battery balance issue. Okay, usually the most I cannot say the most important part. I must say the most tricky part is battery balance issue. How to balance the batteries, and then we'll introduce some commercial BMS ICs. Okay. First, the BMS system. BMS is an electronic system that will manage its renewable batteries. That is, mostly only the rechargeable batteries need the BMS. So the primary battery, that is like button batteries, or the some batteries you used once. We don't need the battery management system for that. But for rechargeable batteries, usually the management system is required, and the BMS system will be an electronic system. That is because usually we have to constantly monitor the status of the battery. So usually we need an electronic system, and more specifically, we need a IC. We need a BMS IC to do the job. Okay, and the task of the BMS includes first to monitor the battery state, then including the battery voltage, battery current, and or battery temperature. Then you have to protect the batteries from operating outside the safe operating area. That is to keep the operation of the battery within the safe operating area. And the third is to calculate the secondary data and report. The BMS will measure the primary data, like voltage, current, and something, and then it has to use the data, the primary data, the raw data, to do some further calculation and get another status of the batteries, and then generate a report and send it back to some superior management system people or something. Okay, and then it has to control the environment. Sometimes the BMS IC can control the it has to monitor the environment, like temperature, and if temperature is too high, it has to reduce the temperature, okay, by stopping the operation of the battery system. And then the authenticate is not so clear here. I think most of the other functions you can understand them very quickly, but authenticate is somewhat not clear. But later we will explain it more clearly. And finally, the charge balancing. Okay. We usually say a battery system, or say we call it battery pack. The pack will be constructed by several battery modules, and usually in the module there will be integrated BMS system inside the module, and then the module will be composed by several cells. The basic unit of the battery system will be the cell. Okay, and however, usually the battery cell itself cannot be used directly, usually because there is no management system on the cell level, and usually the module should have the BMS system. And sometimes the battery pack will also have its battery management system. That is optional on the pack level, but module level is required. Okay, so here the battery pack is composed of several modules, and within a module there are several cells, and the cells inside the modules may be parallel or series connected. Okay, like if we say a battery module is 2P6S, that means there are two parallel and the six series connected. Okay, so totally there will be 12 cells inside the module because 2 times 6. Okay, uh, a module should be equipped with its BMS system, and the battery pack might also have its pack level BMS. Then I will introduce the tasks of the BMS system. The first one is to monitor the status of the batteries, including the voltage, current, temperature. As I said, the voltage might be the individual cells voltages. Okay. Every cell has to be monitored. Okay, and sometimes the total module or total pack, total module voltage also can be monitored. However, the on the module level, the BMS system has to monitor every cell's voltage, and then it can easily combine, add up all the cell voltages. Then we have the module voltage. There is no any difficulty there. And then it helps to monitor the current of the battery. Usually because the battery pack, we use the battery pack as a whole, so we only monitor one current, the pack current, and the pack current maybe just equal to the module current. Okay, we have to monitor only one current, but the system has to monitor many voltages. Okay, current only one, but the voltages there are many. Okay, and the system has to also have to monitor the temperature, maybe the average temperature, maybe the temperature of each cells, or even the temperature of the coolant. Okay, for the battery pack, there should be some temperature reduced mechanism. Okay, sometimes air cooled, sometimes liquid cooled, and the BMS system may also have to monitor the coolant intake or output terminal terminal temperature. Okay. And basically, the BMS IC itself may monitor the die temperature itself. Okay. And then the second one is to protect. The BMS have to protect the batteries from operating outside its SOA, its safe operating area. The SOA is surrounded by the limitations. Yes, there are limitations. The limitation composed of too high current, or too high voltage, or too low voltage. Okay, too high voltage usually happens when charge the batteries. The voltage may be too high, or when we discharge the battery, the voltage may be too low. We have to prevent the too high or too low voltage of the batteries, and then we also have to prevent too high or too low temperature for the batteries. Okay, too high temperature usually because of the heat produced by the battery system itself. So if we want to prevent the battery system from the too high temperature, we have to stop the operating of the battery system. Sometimes charging, sometimes discharging. If the temperature is too high, we have to stop the current. And if the temperature is too low, okay, when the temperature is too low, usually the BMS system cannot do anything. But it can stop the operation of the battery system also. Okay. And then the BMS have to protect the batteries. How the BMS can protect the battery? Actually, there are few methods. There are few actions that the BMS can take to protect the batteries. There will be the internal switch. The switch may be a solid-state switch or a relay. Both is fine. Both are okay for the purpose. But there is a switch, and the switch can be turned off. Okay, the switch can be turned off to cut off the current into or out of the battery system when necessary. Okay, basically outside of the SOA, it has to stop the operating of the battery system. Okay, and usually the BMS system has a communication, and it can communicate with a charger or communicate with the load. When the battery is when it is necessary, the BMS system can request the charger or the load to reduce the current or even stop the current. And the calculation of and the report means the BMS can provide additional information about the battery. The information may include the state of charge, the SOC, or the depth discharge. Okay. Both SOC and the DOD, the depth of the discharge, indicate the charge level of the battery. And the state of health, the SOH. And the SOH is a measurement of the remaining capacity of the battery. And usually it is represented by the percentage of the original capacity. Okay. Last week we have introduced the SOC, DOD, and SOH. Okay. Here it is stated that it is variously defined. That is because SOH actually is not clearly defined in literature. In our definition, it is a percentage of the current maximum capacity over the original capacity in our definition. But sometimes in other literature, some other definition will be given. So it is said it is variously defined. But I think it is very popular. Our definition now is very popular in the references. Okay, and maybe the energy delivered since the last charge or discharge cycle is calculated and provided to the other sources. The energy, of course, the unit may be the kilowatt hour or something, and then the internal impedance of the cell. This information usually can be used to determine the open circuit voltage, and later I can use a figure to explain this more clear. And the charge delivered to generate the charge delivered or restored into the battery, it is very easy because the BMS has to monitor the current. Okay, it has to monitor the current. So if we can constantly do the integration of the current over time, then we have the charge. Okay, and the unit may be the ampere hour. And the total energy delivered since the first use, that is the total energy delivered since this battery started to be used in the application, and maybe the total operating time since first use, and or total number of the cycles. Total number of cycles usually is important since this information is useful for forecast the remaining service life of the battery. Okay. Okay, here the certification. Authentication is required because usually the battery may be replaced because of the damage, because of the out of its service life. We have to replace the battery. Of course, now we are talking about the rechargeable battery, and we have to make sure we replace the correct battery type. Okay, sure, we have to replace with a new battery, but the new battery should be suitable for the application here. We have to put the correct battery here. So we have to do the authentication here to make sure we have the right battery. Um, the reason may be because safety. Of course, you have to put the correct battery. Otherwise there may be some hazard uh, because of the new battery, and maybe the reputation of the company, or maybe to prevent the counterfeit of the battery, and or even the profit of the company. Okay, and earlier days, the form factor is a type of authentication. The form factor means the shape of the battery. Okay, the shape of the battery, the battery of different shape maybe not fit into the case of the battery. Okay, so or the connectors, the round connectors cannot fit to the battery. So this is also a method of authentication. Okay, and before the battery can be used to charge or can be used to function, the authentication process should be finished, should be verified. So after that, you can use the battery. This is authentication. And the communication, the controller of the BMS usually have to communicate externally with a higher level hardware, maybe like your system, the laptop or the human man interface, okay, or others. Or it internally, it has to communicate it with its hardware to operate at the cell level. Okay, so externally or internally, there will be the communication requirements. And of course, for low voltage systems, the centralized BMS, they do not have the requirement to the internal communications. Only the external communication is required. And for the external communication, usually an existent communication protocols is applied here. We don't invent the self-defined protocol. We use the existent protocols such as the UART, SPI, I2C, and so on. These are serial communication protocols, and maybe it can apply the CAN bus communication. Of course, you know, CAN bus is originally invented for the automobile. Okay, so for automotive applications, the CAN bus is popularly applied, or sometimes the wireless communication is required for your BMS system, like Wi-Fi, Zigbee, or something. In summary, the communication is one very important function for the BMS system. And then I will spend a lot of time on the balancing issue. Here, in order to maximize the battery's capacity or prevent localized over discharge or overcharging, the BMS has to actively ensure that all the cells of the battery stream are kept at the same voltage or SOC through the balancing. Here, it is saying that the BMS has to take some action. Okay, the BMS has to take action actively to prevent the over discharging or overcharging of the battery. Here, it is not so clear that why the balancing issue will result in overcharging or discharging. Here is not very clear, and later I will explain that. Anyway, the balancing function want to make sure the SOC of every cells inside the battery string to be the same. And because the voltage and the SOC, they are closely related. So we say we have to keep the same voltage or SOC of every cell. Okay. And there are three methods. There are three methods to achieve the balanced state. First one is to waste the energy. It sounds very weird, right? We just waste the energy. But here it says, when we have the most charged cells than others, that means some cells are more charged and the others are less. So in that case, we will just waste the energy from the most charged and make them the same voltage or the same SOC. Okay, and how to waste the energy? How to waste the energy? It's very simple. Connect them to the resistor to dissipate the energy. Okay. It's very weird. It's very weird. But okay, later we will discuss it. And the second method is to shuffle the energy from the most charged to the least charged one. Okay, we just transfer the energy from the higher SOC cells to the lower SOC cells, and they will have the same SOC. It sounds very reasonable, right? And in this method, there are no apparent energy waste compared to the first method. Okay. And the third one is to control the current. For example, control the charging current. When the SOC is higher, we reduce the charging current. And for the lower SOC one, we just increase the charging current. So their SOC can reach the same. Okay. Or otherwise, when we discharge the battery, we can increase the discharging current of the higher SOC cells and reduce the discharging current of the lower SOC cells. We can also achieve the same SOC of the cells. Okay, there are three kinds of methods.